Hello everyone, in this video we're going to be solving a rational equation. If you like this video, please comment, like and subscribe and hit the bell button for notifications. And let's get started. So in this equation we're going to be finding the real solutions, and there are different ways to go about it. First of which we're going to turn this into a quartic equation. So that's kind of like the usual way, right? I mean, you can just go ahead and make a common denominator that start with, so the common denominator is going to be the product of these two things. So if you make a common denominator, this should look like x plus 2 quantity squared plus x squared. That's multiplied by 9 when I do the cross multiplication, and then 10 multiplied by the product of these two things. Okay? Let's go ahead and expand this. X squared plus x squared is going to give me 2x squared. Then I should be getting 4x plus 4. Then I'll multiply that by 9. And then this is going to be, look like 10x squared multiplied by x squared plus 4x plus 4. Okay. If we distribute, we're going to get 18x squared plus 36x plus 36. And then on the right-hand side, we should be getting 10x to the 4th power plus 40x cubed plus 40x squared. Now, if you put it all together, obviously, this is going to be a quartic equation, 10x to the 4th. We have on the right-hand side, and then there's only one x cubed term. If you bring this 18 over here, 40 minus 18 is equal to positive 22 x squared, and then 36x you're going to subtract minus 36x, and then subtract the constant. That's going to be 36, and the whole thing is equal to 0. And notice that this is a quartic equation, and you can divide everything by 2 here, which simplifies the problem a little bit. Doesn't help a great deal. And solving the quartic is somewhat challenging, right? Obviously. So instead of this, what we're going to do is we're going to use another method. So we could call this the first method. Obviously, from here you can find the roots. But the second method is actually what I want to talk about today. All right? That's the cooler method. And that method actually is substitution. And we've done similar problems before, so you'll hopefully remember. But in this equation, and our original problem is 1 over x squared plus 1 over x plus 2 squared, and the sum is equal to 10. And obviously, here one can just, guess and check some solutions, but the idea is making sure that we have no other solutions besides these. Okay? So that's what we're going to do. Make sure that there are no other solutions, or there are no other real solutions, because obviously there's going to be some complex solutions which we're not going to consider that much. So how do we proceed? We're going to use substitution, and I have to pick something that would make sense here, and that happens to be the average of x and x plus 2. And you'll see in a little bit, this strategy is sometimes used with radical equations as well as some sum of powers. Like if you had something like x to the 4th power plus x plus 2 to the 4th power, we would use a similar strategy. So it makes sense. It's commonly used. And that strategy is basically, what is the average of x and x plus 2? Let's start with that one, okay? The average of two things is basically you add them up and divide by 2, and this should be x plus 1. So x plus 1 is what we're going to call u. Awesome. This means that x is equal to u minus 1, and x plus 2 is going to equal u plus 1. So that's the beauty of this method, that it's going to give us some symmetry. That's what we're looking for, okay? So if you go ahead and replace x with, well, you can do either way, but I'll probably just replace it right away. Replace x with u minus 1. So it's going to look like 1 over u minus 1 quantity squared plus x plus 2 will be replaced with u plus 1. That's going to be u plus 1 squared, and the whole thing is going to equal 10 over 9. Okay, so what are we supposed to do here? Well, we got the symmetry. Obviously, we're going to make a common denominator. Let's go ahead and do that. So this one is going to have a u plus 1 squared plus u minus 1 squared. That's the numerator. And the denominator is just going to be the product. So since these are conjugate terms, I can just go ahead and write it as u squared minus 1 quantity squared. And then this is going to equal 10 over 9. Now we can just go ahead and simplify the numerator and then do the cross multiplication maybe later. This is going to be u squared plus 2u plus 1. And the second part is u squared minus 2u plus 1. So that's the beauty of it, obviously, that we basically get rid of some of these terms, and it makes the problem easier to solve. Okay, that's the whole idea. And here, obviously, 2u and negative 2u are going to cancel out, leaving us with 2u squared plus 2 divided by u to the fourth power minus 2u squared plus 1. Notice that we don't have any term with u cubed, or we don't have any linear term like u. Therefore, this is going to turn into a biquadratic, which is basically a quartic, but a special type of quartic. Okay, so let's go ahead and do the cross multiplication. If you distribute the 10, you should be getting 10u to the fourth minus 20u squared plus 10. And on the right-hand side, I should be getting 18u squared plus 18. Now, to make it a full quartic, I'm going to put everything on the same side. So it's going to look like this. 10u to the fourth minus 20 minus 18 is negative, negative 20 minus 18 is negative 38. U squared and 10 minus 18 is negative 8. Okay, cool. So this is my expression, finally. And I can go ahead and divide everything by 2, obviously, which is going to make it a little easier to solve. Okay, now, why do we call this a biquadratic instead of saying just a quartic, right? Because it's missing some of the terms. And the nice thing about this equation is that I can actually write it as a quadratic. How? Well, if you just go ahead and do the substitution. So let me, in order to make it more clear, let me write the u to the fourth as u squared squared, and then write this as u squared just in parentheses so that you can see what I'm doing here. Now, I can go ahead and replace u squared with something, right? This is a good time. So let's say u squared is equal to y. Okay? Well, remember I didn't use x because x means something else. In this equation, we're going to go back and do it later. But for right now, let's just call u squared y. So this gives us 5y squared minus 19y minus 4 equals 0, which is a quadratic equation. That's the reason why we like the symmetry, because it gives us a nicer equation. A very much reduced quartic, which is very easy to solve because you can turn it into a quadratic. Okay? All right, cool. So what are we going to do with this equation? You can try factoring it, and it's factorable, but I'm going to use the quadratic formula. Why? Because I like it better. And obviously, you can try for factoring here, but if you use the quadratic formula, then this is going to look like y equals negative b, which is 19, plus minus the square root of b squared, which is 361. Remember, we used this number yesterday, I believe, right? 19 squared is 361. Minus 4ac. So since c is negative, I can just put a plus sign there and multiply the 4 times the 5 times the 4, which is 80, basically, right? And that's going to give us a nice number too, so don't worry about it. Plus 80, and then divided by 2 times a, which is 10. Okay, cool. Let's see if this is going to simplify anymore. Well, first of all, we have to take care of the radical here. What is 361 plus 80? That should be 441. That's actually a number that I remember from a long time ago. For some reason, that number just stuck with me. And 441 is 21 squared. So in other words, the square root of 441 is equal to 21, which makes this problem a lot easier to solve because the answers are going to be rational. Cool. So y is going to be from here, 19 plus minus 21 over 10. Now, at this point, we can go ahead and split it up to get our solution separately because the plus minus doesn't really make much sense here. If I use the plus, 19 plus 21 is equal to 40. 40 divided by 10 is equal to 4. So from here, my first solution is going to be y equals 4. My second solution is going to come from the minus sign. If I use the minus sign, 19 minus 21 is equal to negative 2. And negative 2 over 10 is negative 1/5. So my second solution is going to be negative 1 over 5. Great. But that's not the end goal. We're not trying to solve for y, nor are we trying to solve for u, but we're trying to solve for x. So what we got to do is, first of all, turn this y into u and turn the u into x. Okay, how do I do that? Let's go back and see what formula we use for substitution. Well, we assume that u squared is equal to y, or that's how we named it. So u squared is equal to y, meaning that this is u squared and this is u squared. But notice that the second one does not give us real solutions. If you actually wanted to solve it for non-real solutions, then you could say, okay, u is equal to the 1 over square root of 5 times I, and with the plus minus sign, right? So you could use the I into, you could use the complex roots here, but we're going to focus on the real ones. So this is my main focus. U squared is equal to 4. And as you know, that gives you two solutions because there are two numbers whose square equals 4. And those numbers are u equals 2 and u equals -2. Now, here's a question. Are both of these solutions valid? Good question. We're going to go ahead and check, right? Because we manipulated this equation, we've done some substitution. We haven't really squared both sides. We just made a common denominator, so things should be fine. But in rational equations, you always have to check your solutions because they may not work. They may work originally, like after you make common denominators, but they may not satisfy the original problem because there are some denominators that could be 0, so on and so forth. Now, what was my original problem? Let's take a look at the very original equation. And the very original equation gives us something like this, right? 1 over x squared plus 1 over x plus 2 quantity squared is equal to 10 over 9. So what we would like to do here is plug these values into that equation and see if that's actually going to work. But these are u values, right? How do you find the x values? Well, we got to remember what we used for substitution. What does u stand for, right? In other words, well, remember, we've taken the average of these two numbers. So u was equal to x plus 1. U is equal to x plus 1. Okay, cool. Then if u is equal to 2, then x must be u minus 1, right? I mean, from here, you can safely say that x is equal to u minus 1. If u is 2, then x must be 1. So that's one of the candidates. If u is equal to -2, which is valid, right, so far, then x is going to be 1 less than that, which is -3. So we're going to go ahead and substitute these numbers and see if they work. And if they do, then we got our solutions. And the other ones are complex. We already talked about it. Okay. So if x is equal to 1, we should be getting something like 1 over 1 plus 1 over 3 squared, which is 1 over 9. And that's equal to 10/9. So x equals 1 actually works. Cool. What about the x equals -3? Well, if you square -3, it's going to be 9, 1 over 9 from here. And x plus 2 is -3 plus 2, which is -1. And if you square that, you're going to get 1 from there, 1 over 1, whatever. And this is also going to be 10 over 9. So both of the solutions satisfy the original equation, which is not a huge surprise, but we still had to check this. Therefore, this is our solution set, and this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed this video. Please comment, like, and subscribe. And I'll see you tomorrow at the same time with another video. Until then, be safe and take care. Bye-bye.